Since area is finding squares, or the number of squares that fill a space, we can find squares easiest through rectangles. And essentially all areas can be thought of as, rectangular spaces. So if I have a parallelogram here, what I can do is I can take this parallelogram and make an equivalent space that is a rectangle. So to do that, what I can do is I can take this end here, so I can chop off this triangle, and I can add it on to this section here. And what ends up happening then is I end up with a rectangle that has a width of 12 and a height of 7. And this width that I cut off here is going to be added on here, so the total width ends up being 12 here and 12 here, so it's the same width. So really, to find the area of this parallelogram, I'm just going to make it into an equivalent rectangle, and then I have length times perpendicular height. Again, we need a perpendicular measurement, otherwise we won't get squares. And that gives me this area inside here. And that area that I've colored in yellow is equivalent to the blue area. So the area of this rectangle, or this parallelogram, is going to be just 12 times the perpendicular height, and that gives us 84 centimeters squared. For a triangle, essentially what we're going to do is there's two ways we can think of it. We can think of it as we can double this triangle and end up with a rectangle. So we can take base times a height of 8 and divide that by 2. That's what our formula shows. We could also take this section out here, go halfway along the length. We can take that triangle here and we can reposition it up here. Okay, so that equivalent triangle here and here means that this space that I'm going to highlight in yellow is equivalent to the blue space that we have started with, the blue triangle. And now this yellow area is going to be half the base times the height, which gives me the area of that triangle. So I'm going to take half the base times the height, and that's going to be equal to the area, which is 40 centimeters squared. And if I were to use the triangle formula, it's just going to be base divided by 2, which is going to give me 5, times the height, which is 8, and that's going to give me the exact same area, so the area is conserved. For a trapezoid, there's lots of ways we can do this, but one way we can do this is we can take this section here. That triangle then can be repositioned over here. So we're going to take away this space, we're going to add that same space to there, and by doing so, now we've generated a rectangle of that space. And if this length here is 5, okay, we can just shift everything over, and we end up with this length here of 12 plus 5, okay, which is going to be half of the distance across. So this 12 centimeters, so this is going to be, I should show this. Okay, so this is a little bit wrong here. If this is 12, this length here, the 12 should come across to here. Okay, so that length here is 12. Okay, we're going to take 12 plus 5, and then we're going to find out the area of that by doing 12 plus 5. And then we're going to take that length and multiply it by the perpendicular height, which is 10, and we get 170 centimeters squared. Okay. Now, the other formula that we can use is we can take the formula for a trapezoid looks like this: A plus B divided by 2, and that's times the height. And we can get the same thing here by looking at this diagram. If this length is 12 in between here and here, and this is 5, this must also be 5. So the bottom length is going to be 17. The top length, sorry, bottom length is going to be 22. Okay, so I'm just going to draw it out 5, 12, 5. The bottom length is 22. The top length is 12. Okay, we take that and we're going to divide that by 2. So 12 plus 22 is 34, divided by 2 is 17, times the height. And notice that this amount here is equivalent to this amount here. Okay, so we get 17 times 10. Here we get 34 divided by 2, or the average of the two lengths. And we multiply that by 10, and we're going to get the exact same area of 70 centimeters squared. Okay, so this is from the formula, but we could also just rearrange this trapezoid to get the exact same result.